Hello, today we're going to be solving systems by graphing. So it's leading us into basically the first day of Unit 5, which is all about solving something called a system, which up until this point, none of what we've been working with has been considered a system. So the first thing that we're going to kind of go over, and this is more a review obviously from last unit, but what I want you guys to do obviously is I want you guys to just pause your video and try the Ignite at the top of the page. Okay, so final answer for this one, obviously the directions say graph the given equation. So to do that, remember to graph any equation, the first thing that we have to make sure is that it's actually in slope and intercept form. So, oh my gosh, that was so awful. So slope intercept form is y equals mx plus b. And the goal is, remember, is that if you're in slope intercept form, then the number in front of x is your slope, and the number on the end is your y-intercept. So the key, though, is that in order for that to happen, y has to be alone. So when you look at the problem that we have here, y is not alone to start. So in order to actually graph this, we have to get y by itself, divide everything by 3. And then obviously the number in front of x, if I take -1 divided by 3, we get our slope, which is -1/3. And my y-intercept is going to end up being 3. So we are going to start by, you should have plotted your y-intercept, gone up 3, plotted that point. And then the slope, really at the end of the day, if it's -1/3, the rise is -1, the run is 3. So in graphing world, if I'm rising negatively, that's down. And if my run is positive, it just means we're going to the right 3. So I just continually did that, down 1, right 3, down 1, right 3, down 1, right 3, and I plotted all of those points. Now remember, you can reverse that. Instead of going down 1, right 3, you can also go up 1, back 3. That's also the equivalent, the same thing basically. Okay, but remember, for graphing a line, especially for today, you want to make sure you fill in as many points as possible, because we're going to actually use those points to do what the whole goal is for today, which is obviously something called solving a system. Now, probably your next question is going to be, well, Ms. Hardy, what exactly is a system of equations? Well, when it comes to something being a system is simply just a group of 2 or more equations that are grouped together. And it's basically like they're part of the same problem. Now what happens is, especially when we're graphing, when it comes to systems, the equations that we're really going to work on, I say 2 or more, but in Algebra 1, we're really going to focus on just 2 equations graphed together. And when you graph 2 equations together, there's some different things that happens. I'm going to come back to the solution definition for just a second, but when you have 2 lines graphed together on the same graph, what happens is that the solution is something pretty specific. And it depends on kind of how the lines are graphed. If you're kind of scenario number 1 is if your lines are graphed and they cross each other at some point. When we talk about the solution to any system, and now I'm going to fill this in, it's simply just the point where the lines cross. That's really, honestly, in one sentence, that's the whole goal for this entire unit. Is if I'm asking you to solve the system, we're trying to find the point where the 2 lines that we're going to graph are going to cross. If it was a 3 equation system, we would look at the point that all 3 lines crossed each other at. Now, obviously, there's different scenarios, right? Like, and actually, we're going to talk about what the solution is for these scenarios anyways. But the reason why when you have 2 lines that cross, why it's considered to only have 1 solution, that's because they only cross at 1 specific point. So if we look at that, if I was going to say how many solutions are there, well, this one, my lines cross, so there's going to only be 1 solution. And it's at what point is it where they actually cross? Well, I go right 2, up 2, 3, 4. So that solution would be at the point 2, 4. Now, there's obviously other scenarios of things, right? Because my lines actually don't have to really cross. If we look at the next scenario, well, what if your lines have the same slope? What if they increase or decrease at the same exact rate? Then you actually never are going to reach a point where those two lines cross. These are what we call parallel lines. Those are lines that never cross. So if they never cross, if the question is where do they cross and they never do, then this is actually a case, we would actually call this no solution. Ooh. The answer to this would be no solution. Oh my gosh, that was so awful. You guys know what I'm trying to write, right? No. That's a little better. There we go. So if I asked you what is the solution, you would say this one literally has 0 solutions. There is no solution to that graph because those lines don't cross. Now there is another scenario, and it's where you have infinitely many answers. And it's kind of hard to picture, but I'm going to graph the other line. So if I think about the red line, there is another option. And that's what if your lines overlap each other completely? If your lines actually truly end up being the same line, which that is a case, you could graph a system where both lines are the same. And all that means for us is just that, well, where do those lines cross? Well, they cross everywhere. They cross here, here, here. Everywhere the blue line overlaps the red line, all of those are made up of points. And that just means we have infinitely many solutions. So when we have lines when we graph systems, we really always have 3 options for answers. If my lines never cross, we would say no solution. If my lines end up being the same, which is like at example C, that the point where they cross at all points. So you would say infinitely many. Or they cross at one individual point, and we would notate whatever that point is. So typically, I will say we don't deal with as many no solutions or infinitely many's, but we're going to go through and we're going to actually start to see, well, what is the answer? So let's do an example. So if you look at example 2, the directions say determine whether the system has infinitely many solutions or no solution. So these two, I'm only graphing 2 individual ones. So if I say solve by graphing, that means you actually have to graph these lines. So I'm going to do the first equation in blue. And we're good to go right now. Because remember, to graph any line, we have to make sure we're in slope-intercept form first. So is y alone in this one? Yeah, it totally is. That means I can graph. My y-intercept is going to be up at 1, and I'm going to plot that point. And then my slope, technically the number that's in front of x, technically it's a -1 over 1. So that tells me I'm going to take turns going down 1, right 1. Now, typically, this is why we want to make sure we fill in as many points. Doesn't really matter as much for this one because all of the points, it's really just, these 2 lines are either not going to cross or they're going to cross. But if your lines are going to cross, you usually want to know at what specific point is it actually going to cross at. So let's see if I got this. That was not my best line, but you guys can hopefully picture that's supposed to go through all the points. So now let's go through and graph my second line. I'm going to do this one in green. So this one, the only difference is I start up at 4. And then this one actually has the same slope. My slope on this one is going to be -1 over 1. So I'm going to take turns going down 1, right 1 for forever. And you're going to notice that these slopes are the same. Every time I rise 1, run 1, the other line does the same exact thing. And when that happens, you've just created what are called parallel lines. And that just tells me that in terms of, that means that if I'm trying to find the point where these cross and they never cross, your final answer on this one, you would just say this is a no solution. All right. Another way of thinking about it is if they have the same slope, but they start in different places, that's kind of the perfect scenario. That's the scenario that will always produce no solution. Now the other one, for this one, if I'm going to graph this, my first line is actually good to go. I'll graph it in green because y is solved for, so I can graph this right now. I'm going to start up at 3. And then my slope, technically my slope is a 2 over 1. So I'm going to take turns rising 2 and running 1, or going down 2 and back 1 for as many points as possible. So let's fill in all of our handy dandy trusty points. Fill in my line. That was not my best line. I got most of the points though. Now we do have an issue on the second line, because the second line, this one, y is not alone, which means my slope is not 8. We have to make sure, in order to look at the slope or the y-intercept, y we have to solve for. So first step is always going to be to move the x term over to the other side. I'm going to put the negative 8x in front of the negative 12. And then last step is divide by the number that's in front of y. And we're going to now be able to graph this. Negative 8 divided by negative 4 ends up being positive 2. And negative 12 divided by negative 4 ends up being a positive 3. And what do you know? They're the same line. That means they have the same y-intercept, so this one would also be plotted up at 3. And this line also rises 1, runs 1, which means this line is going to basically be overlapping. And if you're going to answer the question, well, where do those lines cross? We have our answer. At all the points, so infinitely many. Alrighty. Now, even if it's a word problem, we can still answer this question. So for this one, example 4, it says, Mariah and Diego love to ride bikes. The equations below show the number of miles they ride, M, based on the number of weeks, W. Predict the number of weeks in which Mariah and Diego will have ridden the same number of miles. So first thing I'm going to fill in for you guys, obviously I'm not going to make you guys choose the scale on this, but we are going to let's start at 20 actually, and then we're going to count by 5s. So my next one's going to be at 25, 30, ooh, that 3 went crazy, 30, 35, 40, 45, 50, nope, not 65, 55, 60, 65, 75, nope, 65, 70, struggle bus. Okay, so obviously this side is going to represent the number of miles ridden, and down here, in terms of the number of weeks that they ride, we're just going to count by 1s. Now, both of these lines, I actually really like how they're starting. So we're obviously, instead of x and y, we're going to be dealing with w and our m-axis. But both of these, we have y essentially solved for. So we can actually graph both of these right now. So I'm going to do my first line in blue. So this one, basically, this one tells me that my b, or my y-intercept, is going to be at 20. And my slope is going to be rise 15, run 1. So let's do that. I'm going to plot my first point up at 20. And then I'm going to rise, so 5, 10, 15 over 1. Away we go. 5, 10, 15 over 1, 5, 10, 15 over 1. And again, try and fill in as many points as possible. But at the end of the day, first line is done. Now my second line, I'm going to do it in a different color. We're going to do this guy in green. So for my green line, the b on this one, my y-intercept is going to end up being at 50. And my slope, or the number before the variable, is going to end up being 5 over 1. So this one's kind of odd. This one actually starts off way more. So my y-intercept is 50, and then I'm going to take turns rising 5, running 1. And these lines don't form either of the scenarios that the last two ones did, because these actually cross. So what you just found, this is the point where those two values are going to end up being the same. So what we can do right now, you have your solution. What point is that? That's going to be, we went right 3 and we're going up 65. So what this tells us is that, remember, if 3 is W and 65 is M in this case, this just means it takes basically 3 weeks for you to ride the same number of miles, which ends up being 65. All right. So predict the week, you would say week 3. All right. So obviously now's the time if you want to pause your video. You can, if you want to try the 2 view triangles at the bottom. I will be going through these as well. But while you wait, you can move on and you can start working on the homework for today. Thanks, guys.